earlier, and I'm sorry if I forgot to record the discussion at the start of the lecture here, but the main point takeaway is that simple linear regression is where you have one independent variable affecting a dependent variable, such as hours of study affects GPA. We said that you typically would plot the independent variable on the x-axis and the dependent variable on the y-axis, and then given an x value, like hours of study in this case, we can either use a graphical method or the actual equation of this regression line to compute what the predicted GPA is. So from this, we can predict this, either just by extending this line up where it hits the regression and bringing it across, or looking at the equation of the line as in y equals mx plus b and substituting in the y-intercept and the gradients and the x value, we can predict what y is. Whereas multiple linear regression is when there's multiple causal factors, such as your GPA being impacted by hours of study, plus also whether you're working, plus also how difficult the course is, plus also your family support environment, plus also other things. So it can be caused by a number of or multiple factors. And so we build a multi-dimensional model. This is where I want to kind of go to now and do something more practical. So we'll go to the next slide and we'll talk about, well, I've got just basically a statement here just to say like what I just said before, that it allows you to predict where there's multiple causal factors. So let's look at applying multiple linear regression. And I've got two examples here side by side, and please ask questions as we go through. And my first example is to do with house prices. So suppose that you want to predict the price of a house based upon its size in, say, square feet and its age in years since construction. So in this case, we think about what the dependent variable is. Remember, the dependent variable is the thing that depends on other factors. So in this case, the dependent variable is the house price. House price would be impacted or affected by the size and the age in years. So we have two causal factors that are causing the house price. So multiple linear regression can help you understand how both house size and house age together influence the house price. That's my first example. If we draw this as a causal diagram, we're just simply saying that house age and house size influence or impact or cause the house price. So there's a very simple sort of causal diagram. My second example is to do with company revenue. So it goes on to say here that suppose you want to predict a company's revenue. So you want to predict the revenue based on its advertising spend and the number of employees. So the dependent variable is the revenue. This is the thing that depends upon these other two things. And advertising spend and number of employees are the independent variables. So again, we could use multiple linear regression to help us determine how these causal factors, these independent variables together influence the revenue. So that's the basic idea here. And continuing this discussion, so just comparing simple versus multiple linear regression. So with simple linear regression, we just have a single cause and a single effect. And the line of best fit, this one I spoke about before, this one here, can be described using this formula y equals mx plus b, which you would have learnt in school. Some people might have learnt y equals mx plus c. So y is the dependent variable, it's on the y-axis, x is the independent variable, m is the gradient or the slope, and b is the y-intercept. It's the point where that regression line touches the y-axis here. So just here, where it touches the y-axis. So it could be a negative number if it touches the y-axis down below the x equals 0 line, or it might be positive if it touches the y-axis above the x equals 0 line. Let's compare and contrast this with, so what does the equation look like for multiple linear regression? So again, multiple linear regression, we have multiple causes and a single effect. So the line of best fit is described not just using one set of coefficients, but multiple coefficients. When I say a coefficient, I'm referring to this slope here. That's a coefficient. M1 is a coefficient, M2 is a coefficient, Mn is a coefficient, and the y-intercept here is a coefficient. So you're going to have multiple x's because, as we said before, see here, you've got multiple causal factors. So this is going to be, say, x1, this is x2, this is x3, this is x4, and this is x5. Let's think about this in terms of the assignment. In the assignment, you're trying to predict customer value based upon some of these other columns. You're trying to work out in the first instance which one of these columns might be relevant to predicting customer value. So let's suppose that after we go through the multiple linear regression process, we determine that the customer value can be predicted accurately by, let's say, and I'm just picking these arbitrarily, let's just say these columns here. We'll just make them a different color. Let's go blue. So what I'm saying here as an example, suppose that after we went through this model building exercise with multiple linear regression, one of the outcomes is that you'll determine which of these independent variables is significant in predicting the dependent variable, in this case, customer value. And let's suppose, for argument's sake, that we've determined that seconds of use, frequency of SMS, and age, these three factors are key determinants in predicting the customer value. Well, we could build a model, a predictive model, by saying, well, this value, I'll zoom in a bit, this value 4,370 is our first X value for the first factor, the first causal factor. This number 5 is the second X value for our second causal factor. And this third number, 60, is our third X value to help us build something so we can predict this Y based upon these different gradients. We calculate these gradients for each of the X values. And we just simply multiply them with the X values, we add them all together, including the Y-intercept. And this is all automatically generated for us. So I'm going to show you in a few moments how to generate these values. And it's surprisingly simple. We just run it through the analysis tool pack regression tool, and it will tell you what the coefficients are. And after we have those coefficients, we can put them together into a simple formula like this. And just by calculating what this is for that particular customer. So if we don't know the customer value, let's put some question marks here. We don't know the customer value, but we do know seconds of use, frequency of SMS, and the age of the customer. We do know those three things. We'll be able to calculate what the likely customer value will be from our multiple regression model. That's the big picture, and I'm going to now demonstrate this. We're going to dive into some details here. I'm going to be using the purchasing data set that's over in week 8. Let me just do that. So here we have the spreadsheet called PLE Purchasing Survey. Let's download it and open this one up in Excel. So what I'm doing now is no different to what you'll need to do for task 2 of the assignment. First of all, let's explain what these columns mean. So suppose that we've developed a survey that we want to give to our customers for our company, and we're collecting data on their perceived satisfaction level on some kind of Likert scale, like an ordinal scale where you ask them questions like, what is your current satisfaction level with our products? And this customer has rated it as, say, 4.2 out of 10, let's say. 4.2 out of 10. And we've also asked them questions on delivery speed, how fast we deliver our products to them, price level, price flexibility, yada, yada, yada. So there's a whole bunch of different factors in here. And this usage level is how much, as a percentage, how much that customer uses our products. So out of the products that they do use that are the same as the products that we sell, what proportion of those products are our products? So in this case, the usage level is 32%, so a fairly sort of low usage level, whereas here we've got a usage level of 63%, which is moderately high. What we're trying to do is we're going to try to predict the usage level. I'll just color code this in yellow. This will be our dependent variable. We're going to try and predict usage level based upon these other causal factors, these other ratings here. Now, we don't know which one of these are statistically significant in helping us predict the usage level. So this is why we're going to run through this multiple linear regression. The outcome will be that it will tell us which of these independent variables are significant in predicting the usage level. So let's start the process. Usually what I like to do is have the independent variable on the leftmost column, and that's the way I've set up this demonstration. And it's also the way I've set up the assignment as well. The dependent variable I put here way over the left-hand side, and these are all the independent variables over here. So what we do first, and the first thing that you will do, which I won't do in this demonstration because we're focusing on how to do multiple linear regression, but in the video that I sent you last week, which is also linked to the bottom of the assignment page, and also it was sent out an announcement last week, the week 7 recorded tutorial, I discussed the assignment, and one of the things that I showed everyone how to do is to do outlier treatment. The example that I used last week is if we were trying to calculate everybody's net worth, how much they're worth, in terms of money, and we had a room full of people, and then in walks Elon Musk, then that would be kind of a weird number to consider because Elon Musk is worth, hundreds of billions of dollars. So we would probably want to exclude Elon Musk as an outlier before we do the calculate the average net worth of everyone in the room. Because if we included the outlier, Elon Musk, that would really kind of make the average net worth super high, and that would not be reflective of the true nature of the sample that we've got. So we do the same thing in the assignment, and if you watch that week 7 recording that's linked to the assignment, you'll see that how I do that by calculating z-scores and then just excluding anything that's above or below 3 standard deviations away from the mean. I'm not going to do that for this example. I just want to focus on the job of doing the multiple linear regression, but you would do the outlier treatment first before you do any of this other stuff. So what we're going to do now is figure out, run our first multiple linear regression iteration. So I need to just make sure analysis toolpack is installed. And now I've got access to this data analysis button here. We find regression and click OK. And then we put in our Y range. Remember, your Y range is your dependent variable. That one's easy. That one's the usage level. I'm going to select the label and all the data underneath as the Y range. That's my independent variable, dependent variable. The X range is the range of all the independent variables. So for that one, I'm going to select all of this and all the way down. So I'm just selecting all of the independent variables over here. Basically all of the stuff on the right-hand side. And we selected labels in the first row. We'll just do a simple one for now. We'll come back maybe and talk about residual plots and so on next time, but we'll just do a simple one. We'll just click OK, and we get this output here. Okay, now there's lots of information here. I just want to summarize a few key key ones. First of all, in the regression statistics, I think the important ones you want to look at, most important one I think would be this one here, and I'll highlight these as we go through. So this adjusted R-squared value, got some notes in the PowerPoint slides, but R-squared tells you that's right. Yep. So R-squared tells you how how well this model fits the data that we're seeing, and this is a fairly high value. This is 0.9179, so I would consider that very strong. Adjusted R-squared takes into account the number of samples. So we did this sort of last time as well. We discussed some of this. So this tells you how well the model fits given the number of samples. Now I don't know how many samples we've got. I think we've got like 100. So there's 100 samples. So you can see it's been adjusted down slightly to factor in that we've only got 100 samples, but it's still a pretty good model. The highest number this can be is 1, and the lowest this can be is 0. So it's relatively strong. There's 100 observations, and we've got some information down here in this analysis of variance output, or ANOVA output. ANOVA means analysis of variance. It gives you the overall sense of the variance of the model, the variance of the data based upon the model that we've built. One key value is this one here, significance F, also called the overall p-value. I'll talk about p-values in a second. A p-value tells you the probability that something is statistically insignificant to predict something else. So I'll just repeat that again. I might put it in the Zoom chat. So the probability of something being statistically insignificant for predicting something else. So p-value, probability that a variable is statistically insignificant for predicting the dependent variable. Right, it's in the Zoom chat. You can just put that in your notes if you like. So this significance F is also called the overall p-value. And overall, you want this number to be as low as possible. Ideally below our alpha threshold, which is generally accepted as 0.05. And this number is actually pretty low. I want you to just see this. This is 8.12623 E minus 42. I want to talk about what that means. This means that we've got a number that looks like this. That E means 10 to the power of, and we've got negative 42. So imagine a number with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Imagine a number with 40 zeros on the front, something 0.0, and there's 40 zeros, and then there's 812,623. Because this really means 8.12623 times 10 to the power of, I'll just use a little caret, to the power of negative 42. It's just scientific notation. That's a really, really small number. So what this is telling us is that overall p-value, or the significance F statistic, is telling us that overall the chance that these independent variables are insignificant at predicting the usage level is very, very low. In other words, there's a very high probability that these are significant in helping us predict the usage level. This is a good sign. This is a good sign that our model is pretty good. Now, going down the bottom here, we've got a couple of variables. These are all our independent variables. And this one here, this first one, is the intercept. Again, I'm just highlighting the things that are important. The intercept. Now, the intercept means the y-intercept. This is where our regression crosses over the y-axis. And this is the exact value for the intercept, this one here. Okay, so we'll just highlight that one as well. The independent variables here, what we're looking at to start off with is the p-value for each independent variable. I'll just highlight the ones we're interested in. We're interested in these ones here. So we're looking for anything which is, and I'll just use conditional formatting. So conditional formatting, we'll just use color scales to help us see the magnitude of these numbers. What we're looking for are numbers, and notice how I didn't highlight the coefficient, the p-value for the intercept. We don't worry about that, but we are concerned with the p-values of all of the independent variables. And there are some here that could not be calculated. So the ones we're looking for, or the one we're looking for, is the highest number. There's a number here, and again, I want to just remind you that the p-value is the probability, like this p-value here. There's a 72% chance that price level is statistically insignificant or has little to do to help us predict the usage level. So we could ignore price level from our model and rerun it because there's a very high chance that it won't help us predict usage level. There's a 72%, 0.72 probability. What do we do with price level? This one here. We're going to go back to here and we're going to delete price level from the model. I'm just going to literally just take this column and I'm just going to delete it because it's not useful at predicting usage level. And now this will affect the other numbers. So let's rerun this again. So we're just doing this a second time. So we go to data analysis, regression. Our y range is still the same, but we need to just update the x value because we deleted that column. So everything from satisfaction level to straight rebuy, and click OK. So this is the second iteration, or the second time through doing the multiple linear regression. Again, we've got some numbers here. We're just making sure that everything is still good. And we want to look at these p-values, and we want to exclude anything which is above our threshold, 0.05. And we're going to start with the highest number. So if we just do conditional formatting. Okay, the next highest number is this one here, 0.506. So again, this means that there is a 0.5 or 50% probability that product quality is statistically insignificant for predicting usage level. So we're going to remove product quality because it's pretty useless. It's way above 0.05 and it's the highest number. So we'll just exclude that next. That was, what was it? Product quality we need to exclude. You're probably wondering, like, why didn't I just exclude like multiple when I did this? Why don't I just take away this one and say this one and this one? Well, you just do it one at a time because each time you exclude a variable, it recalculates the p-value. Okay, so we just do one at a time. So the next highest one is this one, product quality. Just going to go across to product quality in our data set and just exclude that one. And we're going to rerun the multiple linear regression for a third time. The x value has changed slightly because we deleted that column. Just going to select these. So we're slowly just eliminating the noise, the stuff that doesn't help us predict usage level. This is the third run through. And here we have still a good adjusted R squared, still a good overall p-value. And let's look at the individual p-values for these independent variables. We use conditional formatting just to highlight. The next highest value is this one here. It's above our threshold, our alpha of 0.05, and it's the highest one. So we're going to exclude purchasing structure. Purchasing structure. This one here, we're going to dump. And we're going to rerun the regression for the 4th time. Change our X range to accommodate that deleted column. And click OK. Okay. Let's have a look at this. So we're looking for any p-values that are above 0.05. We're looking for the highest one. This is above 0.05, and it's the next highest one. So we're going to remove manufacturing image from our data set. Manufacturing image. That one is useless as well. Rerun. So this is the 5th time running our regression. You're slowly eliminating all the noise. Don't forget this is being recorded as well. I'm going to share this with everyone, and you can just follow this at your own pace if you want to. It's strongly advised that you do just try this yourself on this example, just to make you feel comfortable with how to do it for the assignment. So looking for these p-values, anything that is above 0.05, which is our threshold. This one is the next one. This one is 0.002. So this is actually below our alpha threshold of 0.05. So, and this one is definitely below. You can see this is times 10 to the power of -5. So that's a really small number. You can see the number up here. See that? That's the number. Expressed using scientific notation, it looks like this. So it's a really, really small number. It's well below 0.05. All of these are now below 0.05. We'll remove the ones that we couldn't use for the calculation here. So we're left with these causal factors that are all statistically significant at predicting the usage level. Looks like we've got 8 different independent variables. Now, what do we do at this point? At this point, we've finished eliminating the independent variables that don't matter. We're left with the ones that do matter at helping us predict usage level. So now we're looking at these numbers here. What's important next are these coefficients. So let's highlight these coefficients over here. So these coefficients are just terms in our calculation. Now what we want to do is we want to have something in the form of this. I'm just going to write this on the screen here for us. It's going to look like this. It's going to look like y equals m1 x1 plus m2 x2 plus m3 x3. So we've got 8. Let me just quickly do this. Okay, so if you look on the screen here, we're trying to predict usage level, which is our y value, based upon the first coefficient for our first variable times the actual value for the variable. I'm going to explain what all this means. It looks very confusing at first. So the m1 value. So the m1, I'll just annotate here. The m1 value. Maybe if I put this, up above, fine. So this m1 value, this term here, is this one. Is because the first variable is satisfaction level. Okay, this x1 is the actual x value for satisfaction. We take that x value. So if I know, let's say that Jesse has a satisfaction value of, let's say, for example, 3, I just multiply that by this coefficient, -2.71, 2.71. So this number here, this first m1 term, is this number here, -2.714. So I take that coefficient and I multiply it. Let's say Jesse has rated satisfaction, our first independent variable, this first term here, by, let's say he's rated it as 3 out of 10. He's given us 3 out of 10 stars for satisfaction. I can compute what this term is just by multiplying these two together. Likewise, this M2 coefficient is the next coefficient in our list that Excel generated. This one's for delivery speed. So 1.1996, let's call it 1.2. So this is 1.2. And let's say Jesse, for this X term here, let's say Jesse has rated delivery speed as, say, pretty good, let's say 6. So all we're doing is just multiplying this coefficient by what Jesse rated for delivery speed, and so on and so forth. So all these just work their way down the list. This last term that I forgot to put in, we have to put in plus B, which is the intercept. The intercept is this one. This is the y-intercept, negative 5.11, roughly. Negative 5.11. I'm just rounding it. So after we do all these terms, we calculate them all out. So this is the rating for Jesse's rating for price flexibility. This X term here is his rating for overall service. This is his rating for Salesforce image, et cetera, et cetera. These are all the ratings from Jesse. And this is the last one, which is buying type. As I said, the coefficients are all here. These M terms are the coefficients in this list. So we put all that together, and if we don't know Jesse's usage level, but we know from this survey, we know what he's rated for each of these 8 things, we should be able to calculate very accurately, according to this model. It looks pretty good. You should be able to calculate fairly accurately what the usage level is going to be. We're going to do that in a second. I just want to make sure everyone's understanding how we're using these coefficients. So the first phase through, we've eliminated all of the noise, all the stuff that doesn't matter for predicting usage level. We're left with these 8 independent variables because we've looked at these p-values. They're all below 0.05. Then the second part to this multiple linear regression analysis is we're using these coefficients to build this model to compute what the y value is given these coefficients and given a particular set of x values for these variables here. And if we know the values of these x values, we've already got the coefficients, we can just put them all together into a simple calculation like this, and we'll be able to compute or calculate what this y value is. Please give me a thumbs up in the Zoom chat if all of that so far makes sense, and we'll move on to the model part. Awesome. Thanks, Jesse. Janithi, Kaka, are you guys okay? Alrighty, cool. So, yep, awesome. Thanks, Janithi. So now we come to the third part, I guess, in this whole process, and this is the last part where we build this predictive model. Now, what I'll do is I'll just take a screenshot of this, and I'll put this in the Zoom chat for you. Just because I think this is going to just remind you of which numbers are important. So have a look in the Zoom chat. There you go. Have a look in the Zoom chat, and I've just dropped in an image for you, and I'll just clear this out. Okay, so let's do this. These are important, these coefficients. I'm just going to copy these values over because I want to use them in this worksheet over here. Okay, so I'll just zoom out just a little bit. Hopefully you can still see the screen. And we'll just drop our coefficients just into here somewhere, okay? expand that out. So here are our coefficients from our model. All right, now over here in this column, what I'm going to do is, well, actually, I'll insert it maybe here, might be good. Insert another column. This is going to be our predicted usage level, predicted usage level. And I'll just collapse this a little bit, just so we can see the coefficients. All right, so our predictive usage level. So this is our Y value. So we'll start off with equals, and the first thing we want to do, we said, is we wanted to do M1, which is this one. Maybe if I just tag these, this is like M1, M2, these are all of our gradients, all of our slopes. This is B, our y-intercept. And all of this is our x1 value, this is x2. And we got rid of these ones. So these are our 8 independent variables. Our x terms are all here, that's x1, x2, x3. Here are all our m terms, and this is the y-intercept. There are like gradients. Perfect, so let's put this together. Okay, equals, yeah, so it's just really m1 multiplied by x1 plus m2 multiplied by x2 plus m3 multiplied by x3 plus m4 multiplied by x4 plus m5 multiplied by x5 plus m6 multiplied by x6 plus m7 multiplied by x7 plus m8 multiplied by m8 plus our y-intercept, that b term. So it looks pretty confusing, but we're just multiplying like, x's by the m's all the way along, then adding the b. Now, I'm going to be copying this formula all the way down. I do want the x values to change as we slide this formula down, but I don't want the coefficients to change when I slide this, when I copy this formula down. I want these to be locked into place because they're always at the same cell references. So I need them to stay at the same cell references in column M. So what I'm just going to do is just click into each of the M terms here. I'm just going to hit F4 on the keyboard. If you're using a Mac, if you're on Mac OS, just press function F4. But just to make sure all these M terms are absolute cell references. They're always going to be at the same cell ref. So I'm just going to lock those in, and there's M4. Cool. So all of these are now absolute cell references, but the x's will slide and change as we drag the formula down. I'm just going to hit enter, and we've got this number here. Now, let's double click here to do the rest of them, and we'll change this to say 2 decimal places. Well, let's say the nearest whole number. Let's do the nearest whole number. Yeah, it's just rounded the nearest whole number. And this is my predicted usage level given these x values. Now, I want you to have a quick glance. The first one is pretty good. We predicted 31. Without knowing the usage level, we predicted 31. The actual usage level was 32. That's pretty damn close. The next one was 42. We predicted 42, but it was 43. We're only one out. This one we got spot on, 48. This one we were out by 3. So we predicted 35, but it was actually 32. Just doing a quick glance down this list, just eyeball it, and you can see that these numbers are pretty damn close to the actuals. In fact, what we could do is just measure the variance. and figure out what the difference is. If we take the actual and we just subtract the predicted, we get how much we were off by. Okay, so here the actual is 1 more than we predicted. Here it was 1 more than predicted. This is 0. This is where it's spot on. This is 3 less than we predicted. The actual is 3 less than we predicted. So we can see from the variance, let's just look at the performance of the model. We'll just get the variance and maybe just insert, I don't know, like a bar chart maybe. Now we can see the overall variance of our model. Pretty good, because you can see the variance, it's pretty close to 0. Sometimes it goes like to negative, this one's -7, this one's like 6, but it's pretty close to 0. Like, we're not seeing any crazy numbers where we predicted, say, something that was, say, 20 points out. They're all within a sort of a margin of error of, say, plus or minus 6, which is pretty good. All right, so we've just built a crystal ball, and we've now got a way to tell the future, and we can predict what something will be based upon other things. Now, I just want to do a check-in with everyone, just to make sure you're all okay with that idea of what we said before this. Where was it? You know what I put in the Zoom chat, I'll just quickly grab it. This one here. So we just basically implemented this formula. We took each of the X values in our data set, just to test the model, make sure it's all working okay. We took this X value, we multiplied it by each of the coefficients, and we added on the y-intercept. We put this into an Excel formula and able to predict what the usage level was based upon known X's and these coefficients. Please give me a thumbs up in the Zoom chat if what we just did makes sense with building this formula in Excel. This one here. All right, cool. And then we measured the variance, like what the difference is, what the delta is between the two. We built a little chart just to look at the performance of our model. We can see it's pretty close. Now let's go down the bottom and let's put in an unknown person, okay? So I'm just going to copy this down just one more row. We don't know the actual, we don't know the actual, okay? But we're going to come up with a prediction. And what we're going to do is say, let's say someone's filled this survey out for satisfaction right through to buying type. Let's just suppose that they rated this as, say, 5, this is 6, this is 4, this is 3, this is 6, this is 1, this is 0, this is 1. So based upon this input, we're predicting that their usage level will be 47. Now, we don't know what it actually is, but what we do know is that our model is pretty good. So it's going to be fairly close to this, plus or minus a certain margin of error. And that's just based upon us measuring these 8 different things. We can predict what their usage level will be. For the assignment, you have to predict customer value based upon the statistically significant independent variables in this set. So just like we did today, what you'll be doing for the assignment in the second task is you'll be opening the spreadsheet, you'll be going to data, data analysis, regression. You'll be selecting your Y range. Your Y range is this, customer value. Your X range is everything else. And you'll be just running through this. Click OK, you'll get your regression output, see if it's a good model, look at the p-values. You want to exclude anything which is above 0.05 and the highest one of that set. Just exclude the highest number that is above 0.05 as a p-value. Delete that column from the data set, just like we did here, and then keep going. You have to do many, many cycles in order to get down to the couple of independent variables that are statistically significant in helping to predict Optus's customer value for an unknown customer. And the outcome will be something like this, where you're going to then test your model to make sure it's okay by actually predicting all of the customer values for your customers to see how close it is. You can measure the variance, you can chart it out, you can talk about this in your report. You'll have a set of coefficients that are now part of your model. And you can document all of this in your report. Now we're going to help you in the tutorials this week to help get that report started. I think what I'd like to do this week is help you just get the business understanding sorted and the data understanding. And then we'll also help you with your chart building part as well. Now, this wasn't in the recording. I forgot to record earlier on, but just for the sake of everyone else watching this, we also gave some examples of some dashboards. I was just showing my guys here how to maybe build a few charts. We built a chart of, say, the proportion of customers who had a complaint versus who didn't have a complaint. We built a report on the average calls per customer and the average text messages per customer. We also built a report on total spend or average customer value by age group using a pivot table.